Good afternoon. You hear a machine running in the background. That's not to distract you. That's just because we're going to switch gears here in a second and move from the board here over to the machine so you can kind of see what I'm talking about. What you see on the board is something I've drawn out just to let you realize or let you see. Getting the doors closed here so it's a little bit less noisy. To let you see what conductivity we've got. So if we're looking at a conductivity screen on a scope, which we've done before, you would see this. Okay, if we oriented it in this direction, we've got our phase analysis screen, our vector diagram, whatever you want to call it. We've got resistance along the bottom, we've got inductive reactance along the side, and we've got just our normal screen or our normal shot of materials here. So ferrite, stainless steel 304, copper nickel, magnesium, T6, and O. Okay? I'm going to move over here just to kind of bring your mind back around to the fact that if you've got a vector diagram with resistance over here, inductive reactance over here, and we were looking at the locus curve, okay, this would be our thickness, okay, and that's not a true thickness line, but still can represent it. Whoops, if I can spell right, conductivity line, and this is the line you actually see, or our liftoff line. So if we were looking at this over here, we are only seeing this line right here, right now. Okay? Liftoff, liftoff, so on and so on. But what we're more concerned with, not necessarily our liftoff line, but we're more concerned with increasing conductivity as we go farther and farther down on this line. Okay? We know that any point on this line right here, which we've seen already from the videos in Eddy Current 1 and all of the other stuff that you've been reading, all these points here, these are all different impedance points, right? That impedance is made up of inductive reactance and resistance, but we're basing everything from this bottom left corner over here to say if we were measuring resistance in a circuit carrying only resistance, phase lag is 0. Okay? In a circuit carrying only inductive reactance, phase lag is 90. So any point in here, any one of these impedance points is going to have some phase lag. Whatever that phase lag may be, it's going to be there. Okay? So some amount of phase lag. Now, what we're more concerned with, like we said for now, is just our conductivity lines and how this is all going to play into measuring the thickness of a piece or measuring different materials here. So, basic conductivity curve, increasing conductivity as we come down here, and then ferrite or anything that's magnetic is falling up here, which is kind of how I orient my screens. You don't have to orient yours that way, but it's just easier for me to understand that because I've got inductive reactance, resistance, everything goes up. If it's magnetic, everything comes down. If it's non-magnetic, it's just easier for me that way. So, kind of give you a little shot of what's going on there. I'm going to move you down here, so don't worry about all the wiggling around. Okay, got a different scope here, just to show you that we do have different scopes in the classroom. We've got a UniWest 454 here. Alright, and we're using an older style probe right now. It's an old Nortec probe. Works just fine though. It's a Nortec 2 kilohertz. This is, if you remember from the last video, our paint thickness sample that we were using. Okay, we'll come back to that. I want to get this so we can see it here. So I'm going to prop this up like that. That's a little better. I'm going to null. Okay, here's the reference that I'm using. Right over here. I'm just using these materials here so we can see our line. Okay? So ferrite, I've already oriented this. Titanium, stainless steel, copper nickel, magnesium, aluminum, aluminum. 7075O, 7075 T6. Sorry, T6 is first, then O. So what I want to do now is take that, still looking at conductivity, and compare the two aluminums. Okay? So what I want to do, just to kind of show you a reference up here, let me kind of zoom in over there. What I want to do is take my screen and blow up just this section right here. Okay, I just want to see these two lines and ignore the rest of what's going on over there. So, we're going to do that with conductivity here. Let's get back to the scope there. Alright, there he is. Let's go to, we're going to take on this scope, we're going to take our null point, over here somewhere. So I'm going to take my Y null point. It's going up. I want him down. We'll just go there. It's not really a huge deal on the Y yet. But moreover, I want it over about 4.0 because this is on a 5-volt division. So let's push enter, let's push null. Gets rid of our screen. Okay, there's our one aluminum, there's a second aluminum. But I want to see the end of it. So I'm going to null on this piece of aluminum and lift up. Then come over here. Good. So now you can see we haven't quite blown it up big enough yet, but we've blown up just those two materials. So let's go back up here and add some gain. We're just dealing with one frequency right now. I'm just going to go up to about 30 dB, which may be too high. But we just want to see what happens here. Okay, so I'm going to null. Alright. Whoops, not seeing anything there. Let's re-null. That's better. There we go. Okay, so now we've got a huge separation, or at least a larger one. Let's go back to our location, null point, and take our Y null point and go up with it. You can see the line kind of moving there. We're going to go about 3 divisions. So let's null. Whoops, I dropped the probe. Alright, let's null again. Lift up. There he goes. Here's my 1100 aluminum. There it is. So let's move it over some. Let's take our X null so we can see the end of it. Alright, so if we go 3 and 3, let's null. There it is. Ooh, not enough yet. Let's take it over to 2. Null. Getting closer. Null. There it is. There we go. So there's that. That's better. Let's erase all that. Get a little cleaner. Okay, there's my end of my signal right there. There's the end of the other one. So now we've got a good separation between these two. And if we had, which we don't right here, but if we had actual values, let's just say the conductivity here is roughly 35%. Okay, I'm just putting a number to it. That may not be the actual conductivity, but I'm just putting a number to it. And the conductivity down here, because we know it's lower, like I said up here, we've just blown up that corner right in the center. Alright, so now since we've blown that up, we know that that conductivity down here has got to be something like, let's put a number to it, 45. So 35, 45. So we've got 1, 2, 3, 4, 5, 6, 7, 8 screen divisions. So let's go 1, 2, 3, 4 right in the center. Let's say 4 screen divisions in this case is 5% conductivity. So 35, 40, 45. So if we could find something here that was right on that 40% conductivity, which we don't have anything right here right next to us. Maybe we do. That's pretty close right there. Coming in right about 40% conductivity. So now we've got 35, 40, 45. Now these are rough numbers, but we could at least see, hey, we went to this piece of material right here. Okay, just a little gear looking thing that we've made here at the college. We've got our, let's erase all that, null on our first material here. Lift off. Alright, there it is. There's our 35. Here's our 40. Okay, but I want you to see lift off. So here's our lift off line coming in. There it is. Alright. And then here is our 45% conductivity. Okay, now granted, again, those numbers may not be hard, fast numbers, but they're at least something that you can grasp onto to see what's going on. Okay, so that's kind of how we would do conductivity, just quick conductivity sorting between those two values. Let's do something a little different in another video here. We're going to look at non-conductive coating versus a conductive coating, and then a little bit about thickness to kind of see how all that rolls together. So that's good enough for now. 35%, like we said, here's 35%. Here's our 40%. Here's our 45. Okay, just like I said, rough numbers. Questions or concerns? You know what to do.